Hi, I'm Chris Mills, firefighter with 12th Valley Fire and Rescue's Technical Rescue Team. We've spent the last 5 years improving and rewriting how we perform extrications. In this video, we're going to show you our techniques, what works well for our patients, and what works well for us. After watching this, please work within your specific SOGs and coordinate with your training division to come up with your own techniques. We're going to take you from initial arrival to patient contact and right on through to extrication and transport.
When doing any vehicle extrication, full turnouts with eye protection are required for all personnel in the inner circle. Freeze if any unsafe action is seen and anyone wants it stopped. Now let's review the vehicle anatomy: the roof, hood, trunk, the A post, B post, and C post, the fender, grille, and rocker panel. Whenever you're on scene of a working extrication, there are multiple hazards, some of which are flammable. You should always have a charged hose line capable of 130 gallons per minute flow, staffed by a firefighter wearing full turnouts. The firefighter performs an inner circle, looking for any hazards, external patients, and looking in the vehicle itself. Be sure to check on the ground as well as from above and perform a quick triage of the patients. While doing the inner circle, the firefighter should also stabilize the vehicle. Use the inverted step chocks, placing them under the vehicle in all four corners. Then release the air pressure from the tires to settle the vehicle's frame onto the cribbing. The company officer performs an outer circle, looking for any hazards, external patients that may have been ejected from the vehicle, and any other involved vehicles. Again, be sure to check on the ground as well as from above. Keep in mind, it's common for high-speed collisions to be spread out over half a mile. Once complete, the company officer needs to check for vehicle specifics in the database. This will show any hazards specific to the vehicle, such as airbags, pretensioners, battery locations. Once the inner and outer circles have been performed and the vehicle stabilized, it's time to disconnect the battery. The battery presents multiple concerns. It provides an ignition source, powers airbags, and allows a vehicle to be started and driven away, all while extrication is happening. Open the hood using the grille method. Break the grille out with a Halligan tool. Find the hood release cable and pull it. If it's difficult to pull, try your pliers or Halligan tool. Cut the ground cable first. This prevents a power surge from activating any airbags. Make a second cut on the cable 4 inches away from the first cut. This prevents the cables from coming into contact with each other. Now cut the positive cable. Make a second cut on the cable 4 inches away from the first cut. If the battery is loose, remove it from the vehicle. Enter the vehicle using the easiest means possible. Remember, the vehicle should be stabilized before doing this to prevent excess movement of the patient. Once inside, cover them with a tarp, making sure you're under the tarp with them, explaining what's happening. At this point, a quick patient assessment can begin. Using a spring-loaded center punch, remove all remaining side glass. Leave the front windshield intact. When we remove the roof, it will be important. Using a seatbelt cutter or trauma scissors, cut all seat belts. This is done to prevent patient movement from an accidental pretensioner deployment, as well as to allow unimpeded roof removal. We have found that complete roof removal is the best policy. It allows for maximum patient access and removal.
One of the important steps that we need to take on the cars before we make our cuts is we need to do a peel and peek. We need to expose the inside of the frames before we make our cut. The reason we're doing this is there are airbag cylinders within these cars. The cylinders themselves are over 9,000 psi on some of the models of cars out there, and we want to avoid cutting through those. In order to make our peel and peek, all we're going to do, we're going to take our tool, we're going to come in here, we're going to expose the plastic off. Now I'm able to get a visual of here. Within this visual, I can see if there's any of the cylinders in here. I can also see, like here where we've got additional seatbelt restraints, I can avoid, when I make my cuts, I can avoid those, which is going to save me time. When you're making your cuts, hold the cutter blades at a 90-degree angle to the material you're cutting. This helps keep the blades from splaying sideways and breaking.
Using a reciprocating saw, cut the post of the vehicle. Start with the A post opposite the patient, cutting as low as possible. When dealing with a small or mid-sized car and a patient weighing more than 250 pounds, you need to crib under the B post as well. Keep in mind vehicles have a history of collapsing on themselves once the roof has been removed. After the second post is cut, have firefighters in turnout gear available to support the roof and prevent it from falling in on your patient. Now it's time to remove the roof. Place a firefighter on each corner of the roof, lift the roof up and forward. The two firefighters on the A post should keep forward pressure against the roof as well as keep the momentum going. By peeling away from one corner in a diagonal motion, the windshield will come out intact and easily be removed. At this point, 90% of our patients are ready to come out. Place a backboard between them and the seat. Lean the seat back if possible and slide your patient up on the board. Removing a patient using a vertical method is appropriate only if done properly. Full lifting support must be given to the patient's upper and lower body. The upper torso, lower torso, and pelvis must be moved as a unit. Do not pull the patient using only the shoulders or armpits. Now slide the board onto the trunk deck of the vehicle, suspending the patient's head over the bumper. This location allows for quick placement of board straps, as well as ideal access for placement of C-spine stabilization tape. Once the patient is packaged, place them into the transporting unit to get them on their way to the trauma center. If the patient is not able to be removed, transition into door removal and dash lifting.
Okay, we're going to come in here, we're going to make an initial pinch on the fender here. This initial pinch is going to gap this so it gives us a purchase point to get in with the spreaders. Once we've got that purchase point, we're going to take and blast the entire fender off all the way up to this pinch point. By doing that, I'm going to expose the subframe of the car, and I'm going to make a cut into that subframe. I'm also going to completely expose the door hinges and the lower A post so I can make my relief cut there. When I bring my spreaders in to make my initial pinch on the fender, the blades, the teeth on the blades are pointed backwards. In order to have those bite and hold, when I make this initial pinch, I want to make sure that I've got this end of the jaw, on the spreader jaw here, I want it parallel with the hood. That way when I make my pinch, it bites in there and it holds. As I'm making the pinch, you can see where it's opening up the gap here. Now that I've got that gap opened, I can come in here and displace my fender. The fender's going to be held in at two different locations. It's bolted here at the bottom, and it's also bolted across the top. Those are the 2 points that I want to ultimately push against. Now that I've displaced my fender, I've exposed the subframe of the car, I've exposed my door hinges, and I've also exposed the lower A post. Structurally, there are three things that hold the dash in place. There's the A-post that connects to the roof, there's the subframe that comes out the front of the car, and the lower A-post that connects the car to the subframe on the bottom end of the car. When we get ready to do our extrications, we want to systematically eliminate all three of these structural components. That will allow us to roll the dash much easier. Due to car design and the technology in the metals, it's preferred to cut the hinges over spreading them. By angling the spreader at about a 30-degree up angle when I start this bottom cut, that'll keep the spreader from dropping down into the ground.
Make sure the door is unlocked. At this point, you can usually remove the door by actuating the handle and moving the door up and down. If not, then complete the removal by placing the spreader between the door and the B-post and opening the spreader. Once the door is free, remove it from the inner circle and place it on the ground with the inside of the door facing up. This prevents accidental deployment of a side airbag from launching the door into your scene.
Now that we've removed the door, we're ready for the next step, which is making a relief cut. Where we make the relief cut will dictate where this dash will lift at. If I make my cut down low right here and I ram it, the dash is going to lift right here. Most often in a frontal collision, my feet are pinned up in here behind the pedals. If I make my relief cut down low and I ram the dash, I'll succeed in lifting the dash, but my feet will still be pinned. If I make my relief cut high, about 2 inches above the bottom door hinge, when I lift the dash, the floor pan will stay low where my feet are pinned. The pedals will lift up with the dash and free the patient and their feet. On the relief cut itself, I'm going to come about 2 inches above this. If I've just got solid metal, when I bring my cutters in to make the cutters will tend to rotate into the patient as the blades even out. What we've done here, we've taken our Haugen tool, we've made just a little purchase point to set the blade into. This purchase point, when we close the cutters, will allow the blade to rotate out and away from the patient. When we're making our cut, we want the cut to come all the way through. So we're going to start off all the way on the inside in the passenger compartment, and we're going to continue all the way through to the spot weld of the fender and the firewall. You see that cut is holding the cutter out and away from the patient. My relief cut's complete, my cut through the subframe's complete, my A-post cut is complete. Now we're ready to lift the dash. Some vehicles have a center support brace. This brace is in here so that in a head-on collision, it helps hold the dash from rolling in on the patients. This works against us during our extrication. When we get ready to lift the dash, if this is still intact, the car is going to smile at me. That's going to hold the dash in place. I'm going to lift the two edges. If possible, if the car has that, we want to go ahead and cut that out of the way.
Place a ram on the rocker panel on the patient's side using a ram step if possible. Place the other end of the ram where the A-post makes its bend at the dash. Extend the ram. Once the patient is free, stop the ram.
With a roof cut, or cut in the subframe, and a relief cut where we made it, when I lift the dash, the pedals are going to come with it. As I lift the dash, pedals come up. Once the pedals are up, my patient's free.
Place a backboard between the patient and the seat, then slide your patient up on the board. Again, removing a patient using a vertical method is appropriate only if done properly. Full lifting support must be given to the patient's upper and lower body. The upper torso, lower torso, and pelvis must be moved as a unit. Do not pull the patient using only the shoulders or armpits. As before, slide the board onto the trunk deck of the vehicle. Apply board straps and C-spine stabilization tape. Once the patient is packaged, place them into the transporting unit. Our goal is to make every action count. and have the patient extricated within 10 minutes of arrival. Perform a 5-minute on-scene critique so all involved can learn what did and did not go well. Then pick up and return everything to service. Now let's do a quick review. Upon arrival, do your size up, including who you are, what you have, what you need, what you're doing, and who is command. Pull a charged hose line capable of 130 gallons per minute. When doing the inner circle, check for hazards on the ground, including fuel, power lines, gas meters, or above, including power lines and trees. Stabilize the vehicle. Check for the number of patients in the vehicle and on the ground. Triage the patients. When doing the outer circle, check for hazards on the ground and above as well. Patients that may have been hit or thrown from the accident, and any other vehicles involved in the accident. Disconnect the battery, cutting out a 4-inch section of both battery cables. Remove the glass, including all side and rear glass, with a spring-loaded center punch. Remove the seat belts, cutting all seat belts with a seat belt cutter or trauma shears. For the door removal, pinch or cut the fender on both sides. Cut the hinges. Actuate the handle and remove the door. Place the door out of the inner circle, inside up. Roll the dash. Place the ram into a ram step or use a Halligan tool. Extend the ram enough to remove the patient. Now remove the patient using a seat spine or seat collar. Place a backboard between them and the seat back. If possible, lean the seat back. Slide the patient up onto the board. Slide the board onto the trunk deck and package your patient for transport.
You might have noticed a few of the things that you just saw are different. We're going to show you why. We found that when you break the side and rear glass of a vehicle with a spring-loaded center punch, the glass easily falls. However, when a striking tool is used, the glass breaks into hundreds of pieces and flies throughout the entire vehicle. One of the first things we try to do when we arrive on scene when doing a vehicle extrication is disconnect the battery. The reason we're doing this is to go ahead and reduce the risk of having the airbags blow. We're doing this by taking the power away from the airbags. Keep in mind though, the airbags still can blow. We have static electricity that will still fire off the airbags, and some of the first generation airbags also used a plunger style device, just like the primer on a bullet. Whether you have power to it or not, if this device gets pushed in, the airbags will fire. So bottom line, disconnect the battery as soon as possible. This reduces the chance of having an airbag blow, but always treat the airbags as live. There's always a possibility they will blow on you. We've come up with 3 methods of gaining access to the engine compartment to take care of the battery. First option is by pulling the hood release cable in the passenger compartment. A lot of times though during extrications that does not work great because you've got people inside of the car and you've got people working around that area. So our next option is by using the Halligan tool, which we demonstrated earlier. Or your third option is to go ahead, if neither of those 2 options work for you, third option is to come in here with a hydraulic spreader and go ahead and pinch your fender, get into the hood and pick the hood up. Once your hood's open, take care of the battery, and you're ready for the next step. Many people believe a knife works great for cutting seatbelts. They are correct. Unfortunately, it can also accidentally cut your patient. We use seatbelt cutters or trauma shears. When they're used, the chances of someone getting hurt are slim. Too many times we've seen the roof flapped ineffectively. The same amount of time can be spent taking the entire roof off. This provides for complete patient access and enough room to properly take your patient out. We are trying to cut the hinges on most cars rather than spreading them. This is done for multiple reasons. First reason is when you cut it, the door tends to fall off rather than shooting across the scene. Second of all, when they're cut, the door itself doesn't shake the whole car like it does when you spread it off. And lastly, when you do spread the door tends to move around on you. It can lift the car up, it can crush the feet of people that aren't watching, it can also cut your hydraulic lines. We are now making our relief cuts in the A-post where the wiring harness comes through the car. This is done for multiple reasons. First reason is this is the weakest point of the car. It allows the car to tear. Second thing, if your cutters are having a hard time piercing the skin, by going through this hole you give them a starting point and they cut through a lot easier without breaking the blades. Thing we're doing by doing this is avoiding cutting through the rocker panel. We do not want to cut through the rocker panel. The reason we don't want to do this is most newer cars, they run a fuel lines through here, and they're also running the wiring harness that runs everything in the back end of the car through here. If you do cut through that, you've now introduced fuel into your scene as well as an ignition source. Two things we want to avoid.